Hi guys, Ms. Griffin. We're looking at Unit 7, Skill 5 with graphing rational functions. So we have this rational function and we're looking to find the asymptotes of this rational function and how it affects the graphing characteristics such as increasing, decreasing, things like that. So we have this function and it says graph it and then answer the follow-up questions. So I'm going to start by plugging this into my calculator as a graph. I'll show it to you real quick, but then we're going to plot it on here and talk about all of the other things. Alright, so we are typing in that equation, which is 2 over x minus 2. So I'm going to pull up a fraction first, do 2 over x minus 2, and then move over, and we have minus 2. Lots of 2's in this. So I look at it and I see this nice beautiful curve here and this beautiful curve here. And the first thing we see is something about the x-intercept and the y-intercept. So I can find those easily by looking at the graph. So I'm going to go to Menu, 6, and then option 1 will give me the x-intercept by finding the zeros. So lower bound and upper bound, nice and quick here. And then I have to find the y-intercept just by looking at the table, Control T. So I look here, ooh, that's interesting. At 2 we are undefined. We're going to talk about that in a little bit. I go backwards to where x is 0 and I see negative 3 would give me that y-intercept, 0, negative 3. And then I'm just going to go backwards a little bit and see what we notice happening here. We're getting really close to negative 2 and closer and closer and closer and closer, but it looks like we're never hitting negative 2. Okay, so that's something for us to notice here, and we're going to talk about that as well. Okay, so we're going to try to plot some points on here that are kind of nice, so I'm actually going to go back to where x is giving us some nice values. Let's see. There we go. So we'll start at 0, negative 3, 1, negative 4. We'll go forward to plot these points on our paper as well. Any nice ones that I see we'll plot. All right? So again, we're starting with that 0, negative 3. And we're going to go 1, negative 4, and we know this side went up towards negative 2, but never really hit negative 2. Okay, so we're at negative 2.66, and we just keep getting closer and closer and closer to negative 2, but we're never going to hit it. On this right side at 2, we were undefined, so it's like we can't exist at x equals 2, and we can't exist at y equals negative 2, so that might tell us something in a second. And then as I move further, we had 3, 0 as the x-intercept, 4, negative 1. And then we get really close again to negative 2, but we don't hit it. So really close, really close, really close, but we never hit negative 2, and this never hits x equals 2. Okay, so here's our graph that we have sketched. Had sort of like a wall going at x equals 2, so I'm going to put that in there and we'll talk about what that represents in a second. And then we also had that wall or that ceiling at y equals negative 2. So when I look at this graph and compare it back to the equation, I want to find out why those spots exist at y equals negative 2 and at x equals 2. So when I look at the equation, I see this, I'm still on the highlighter, I see this minus 2 off to the side. That minus 2 tells us about the vertical shift. And it's telling us, hey, shift this graph down too. So we know that at y equals negative 2, we have an asymptote. That's what this is called, an asymptote. And it's horizontal because when we go to y equals negative 2, that line gets plotted horizontally. Okay, I know that part can be confusing. If I look at the vertical asymptote, I notice that it was at x equals 2. So we have to figure out what makes that vertical asymptote. Well, remember back in the early stages of this unit, we talked about how a denominator can never be 0. So in order to get this denominator not equal to 0, then some value of x cannot exist. So I look at this and I say x minus 2 equals 0. Well, when I solve for x, that means x can never be 2. Otherwise, that turns it into a denominator. Therefore, the vertical asymptote is at x equals 2. And again, it's vertical because when I go to 2, I get that line vertically. All right, x-intercept versus y-intercept. So remember we already said that the x-intercept was at 3, 0, and y-intercept was 0, -3. The domain are all of your x values, while range is all of your y's. This is old news, so we're going to go through this pretty quickly. So for the domain, we said we can be every x value except when x is 2. So we're going to say this in two different ways, so you recognize it if it shows up either way. All reals, we can be all real numbers except x equals 2. Okay, but now let's write that in the real notation. We can go from -infinity until 2, but not including 2. Union 2 until infinity. So we can get really, really close to 2, but we can't include it. All right, the range is all the y's. So all the y's that we have here, how low can we go, how high can we go? It looks like we can go as low as -infinity and as high as +infinity, but remember that we cannot exist where y is -2. So this looks like all reals except y equals -2 in this case. So we're going to write that in formal notation though. We can go from -infinity until -2, union -2 until infinity. All right, positive versus negative. Remember, positive is when you are above the x-axis. And negative is when you are below the x-axis. So I look at this graph and I say, okay, when am I above the x-axis? That would be, let's see, I'm going to try to highlight here. That would be this portion. Okay, so that means we are from, let's see, the x value of 2 until the x value of 3. I'm below the x-axis in every spot besides that, so that would be this piece here and this piece here that I have there in red. So that would be from -infinity on the x's until I hit that wall, that asymptote at x equals 2. So until 2, union, and then I can pick up from 3 until forever. And notice that this 2, 3 fills in that gap right here. Positive and negative should always fill in each other's gaps. Same with increasing and decreasing. So when I look at increasing, that's when the graph goes upwards. Decreasing is when it goes downwards, reading from left to right. If I look at this actual picture and I read from left to right, as I follow along it with my black marker here, I'm going down, 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 down. I pick up on the other one and I'm going down, 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 down. So it looks like it's never increasing. So this is not applicable. But it's always decreasing, starting at -infinity for the x's until I hit that wall at 2. Remember, asymptotes work like walls. Okay? And then union, pick up at that wall on the other side until infinity. Okay, what I'm talking about with that wall is when I hit it, right here is that wall at 2, and then I pick up on the other side of it. I'm hitting the wall, but I can't hit 2. I'm starting at the wall just beyond 2. Okay, so it's a wall that I'm blocked on the left side from and the right side from. All right, flip it over. We're going to see another example. All right, so for this one, I'm just going to tell you about the table. We're not going to show it on the actual screen, but I'm going to start plotting some points. I'm going to pause the video and have you guys plot the same points too. So I have these points that I just pulled from the table. Obviously we can't plot the -20 and the +20, but I just want you to see like where the graph is trending towards. Okay, so take a minute, plot as close to these points as possible, and then we'll come back together in just a minute. All right, so I've plotted the points that I could. I just noticed that this was a minus initially and it should have been a positive one, so hopefully you're able to adjust that if need be. So I can clearly see that we have this asymptote at x equals 2, and that's happening because when I look at my denominator and I pull it off to the side and I solve it equal to 0, 2x minus 4 equals 0. Because remember, denominator cannot equal 0, so we add 4. That's 2x equals 4, divide by 2. And that gives us x equals 2. So this is an asymptote, a vertical asymptote, because I am drawing the line vertically. The horizontal asymptote is normally found by looking at the shift over here, but there's no shift. So when there's no shift, what we do is we take the coefficients in front of the x terms. So that would be 6 and 2. And we take that and we divide them. So 6 divided by 2 gives us y equals 3. There's a horizontal asymptote at y equals 3. So if I draw that in there, maybe you recognize, based on the table and based on our picture, that y doesn't ever hit 3. It gets really, really close. You can see at negative 20 it's pretty close, and at positive 20 it's pretty close on the upper end though, but it's never actually hitting 3. So these will exist going on forever on either side, but never actually hit 3. So again, the vertical asymptote, these are two things that we really want you guys to recognize. And the horizontal asymptote are like walls or ceilings or floors, depending on which direction you're coming from. The vertical asymptote is found by looking at the denominator and setting it equal to 0. The horizontal asymptote is found in one of two ways. First, we look for the vertical shift on the end. That's the where we have like f of x plus or minus some value. So it's whatever that value is. Okay, and if that doesn't exist, then we go to option 2, and that means to divide the coefficients of x. And that's what we ended up doing here. That was that 6 over 2, because I look back at the equation, I have the 6x and the 2x. 6 over 2 gives us 3, and it's, of course, y equals, because it was f of x equals that stuff. So x-intercept here is at, let's see. So the y-intercept is the easy one to find right now because we have the table. So it's over 0 down negative 1.25. The x-intercept I didn't show you, but I would have done that menu analyze and then 0. And that gives me negative 0.833, comma 0. So for the domain, that's our x values. Domain goes from left to right. And so we have all options in the world except when x is 2. So here we would say all reals except x equals 2. But I'm going to actually define that in formal notation with that interval notation. We could go from negative infinity until 2, and then from 2 until infinity. Same idea happens with the range. Remember, range goes from bottom to top. Those are your y values. So the very bottom we can go is negative infinity, but then we get stuck, we're trapped, we can't hit that ceiling at 3. So we pick up at 3, and we can go till infinity. So this would look like all reals except 3. Y equals 3, because it's domain. Positive portions of the graph are where you are above the x-axis. So I'm above the x-axis here and above the x-axis here. But we want to be careful about this one. We start at negative infinity. And then I hit the x-axis, of course, at that x-intercept, negative 0.8333. And then I go below it, so that would be in the negative portion. But then I pick up positive starting at the wall, that asymptote of x equals 2. If you can see that right here where I have the asymptote and then the yellow, I can't go to the left of that x equals 2, so I start at x equals 2 and go until forever on the right. So that would be 2 to infinity. Negative is where we're below, so below the x-axis would be anywhere in this screen space. So that looks like from the x-intercept until I hit the wall at x equals 2. And you can see that that would fill in that gap right here. Okay? Increasing is where the graph goes upwards from the left, decreasing goes downwards from the left. So this graph here is going down, this graph here is going down, so increasing is not applicable. Decreasing starts at negative infinity. So I'm decreasing this entire time, decreasing, 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 and then I hit the wall at x equals 2. And then I pick up again, and I start over here at the wall at x equals 2 until forever on the right. So again, the real thing that we want you guys to get here that you haven't learned before, okay, so everything else was review, but what we haven't learned before is this part here. Okay, so this is key. To find the vertical asymptote, we're going to take the denominator, set it equal to 0, and solve for x. So we set denominator equal to 0, solve for x. Because remember, a vertical asymptote is actually x equals some number. Horizontal asymptote is y equals some number. So for the horizontal asymptote, what we do is we take either option 1, the vertical shift, so in case you're wondering, we have that equation f of x equals some fraction and then plus some number. That number is your vertical shift. Okay? If no vertical shift, we need to divide the coefficients of x, then write it as y equals whatever that number is. Okay, so y equals either the division of the coefficients of x or the vertical shift. Vertical shift is your first option. All right, let us know if you have questions. Otherwise, you are working on practice next class.